So here's some miscellaneous algebra topics that didn't really make sense to be added in any of the other lessons, and so I just bunched them all into this one. The topics we're going to talk about is the golden rule of algebra, then x in the denominator, x in the exponent, and in terms of problems. So the golden rule, do unto others as you would have them do unto you, or treat others how you want to be treated. And in math, do unto one side of the equation the same as what you would do to the other side. So you got to be equal on both sides when solving math, when solving algebra. You can do almost anything that you want to one side as long as you also do it to the other side. The whole purpose of doing this is to try and isolate the variable x by itself on one side of the equation. So that's what we're going to talk about here. And remember, you must do the same thing to both sides. By the way, in all these videos, if you haven't caught on to this yet, this is an important piece. Definitions that I throw out there, never going to be tested on the DAT. They don't ask you the definition of things. They want you to apply the definition. They want you to use your knowledge to solve problems. So don't worry about memorizing word for word definitions or things like that. That's not helpful. But it is important for you to understand the concept. All right, so here's a simple example of the golden rule. You have this equation and you're asked to solve for x. And remember, the whole goal is to get x alone on one side. So that's what solving for x means. So first, let's get x on only the left side by subtracting 2x from both sides. There, you can see we're subtracting 2x from both sides. Then let's add 7 to each side, so x is alone on the left, which you can see there. That gives us 2x equals 16. Now we divide both sides by 2, and that gives us 8. So hopefully you can see how we got there. Remember, you can do almost anything that you want to one side as long as you also do it to the other. Now this is an easy example, but this is the principle that you got to use in algebra all the time. Now let's go to the next level and have x in the denominator. When x is in the denominator. Well, this is a lot trickier and a lot more intimidating for most people when you're looking at it. It's a much trickier problem. X is now in the bottom part of the fraction called the denominator. If you're up for the challenge, this is a great problem to practice with. So pause the video and solve it. If you don't know how to do it yet, we're going to do it together. So 3, 2, 1, here we go. We're going to need to find a common denominator so we can actually work with what we've got. I talked about this in my video fractions, so we maybe need to go back to watch that video or rewatch that video. But the least common denominator looks like x times x minus 2 here. So let's multiply the first part by x and the second part by x minus 2. The third side doesn't need to be changed because it already has the correct denominator of x times x minus 2. Do you understand what we're trying to do here? We're trying to make the denominator of all three of these be the same. And that's the thing that I teach in the other video. So here we're just applying it. So let's make that happen. So we multiplied this first one all by x, the second part all by x minus 2, and we didn't need to touch this one because it already has the right denominator. So we can do the math in the numerators, and we actually don't need to do any math to the denominators because they're all the same. So we can get rid of those by just multiplying each part by x times x minus 2. So there's the math with the numerators, simplified down each one. And there's multiplying each thing by x times x minus 2 to get rid of all those denominators. And then simplifying that down, you get 5x equals 9, and then divide each side by 5, and you get x equals 9/5. Now, last step, super important when you're doing these x in the denominator problems, is you need to check and make sure that your final answer is legal when plugging it into the original equation. So for this example, the final answer could not be 0, because that would make this number not work, or positive 2, because that would also be an undefined number. It wouldn't work. 9/5 is totally fine in both of these because it doesn't make either denominator 0, or all three actually. It doesn't cause any issues with these. So 9/5 is great. Now you can do this immediately, or you can just save this for the very end of the test. It's probably easier just to do it immediately because it'll only take about 3 seconds to look at it. But if you're really tight on time and you're at the end of the test, then just keep cruising. Now, what about when x is in the exponent? X in the exponent is a little different because now the goal is to get the left and right sides of the equation to have the same base number. That's this number here, the 2 and the 8. We want those numbers to be the same. That's the first step. So using this example to solve for x, let's work through this. The first thing we need to notice is that 2 and 8 are both powers of 2. So this is 2 to the first, and this is just 2 to the third. That's the big detail to how to get these to have the same number. So let's rewrite this with actually just a 2 as the base for both of those. Do you see how these are the same thing? It's obviously 2 to the x. But then 2 to the third, or 2 cubed, is 8. That's the same thing. Now the way to simplify this is you take 3 times x minus 1, like this. Can you see how we got to this point? We needed to recognize that 8 was just 2 times 2 times 2, and we have the same base now to work with. That's the hard part. Now the math just gets easy, and you just multiply across here to get us down to this point of 2 times 3 to the x minus 3. Now that we have the same base, we can simplify the equation to only the exponents. So we were here. Now we can get rid of these bases because they're the same on both sides, and we can do x equals 3x minus 3. Now this is simple algebra that you already know. Let's get the x on the same side, and here's the last steps to the solution. So you have this. So what I did was I threw a number over here, threw x over there to get us to this point. 3 equals 2x, and then 3 halves equals x. So there's the last steps to get x. X is equal to 3 halves. The last part of this miscellaneous section are the in terms of questions. So sometimes you'll get questions on the test with more than one variable, and it's not possible to solve for x and get a simple answer. In those situations, you solve for x in terms of y, or whatever the question's asking for. You could say y in terms of x, in terms of z, whatever. But to do this, we're going to isolate one of the variables on one side and leave the rest of the variables on the other. So if I said solve for x in terms of y, what I'm asking you to do is isolate for x and put y on the other side. Here's an example of what we're talking about. We are asked to solve this problem for y in terms of x. As always, if you think you can do it, then pause the video, go for it on your own, let's see how you do. For everyone else, here we go. So the question first asks us to solve for y, so we are wanting to isolate y to one side. I always like to put the thing I'm solving for on the left. That's just how I learned it, and so let's do that. So I put all of the y things on the left, and I put all of everything else on the right. Hopefully you can see how I got there. But it got me to negative y minus 2y equals 4 minus x minus 3x. Now we just simplify. That gives us negative 3y equals 4 minus 4x, and then divide each side by 3. Oh, I can jump right to the number on the right, but I want to show you what I did in my brain to how I got to that on the right. So when I divide by negative 3, my brain jumps right over to that answer on the furthest right side there. This answer right there. But let me show you what was happening in my brain that got me there. So first I divided each side by negative 1. So now we have this 3y equals negative 4 plus 4x. And I swapped these around because I like how it looks with x in the beginning and a positive number at the beginning. And so that gives us 3y equals 4x minus 4. And then finally solving for y, dividing by each side by 3. That's what got us to here. You could do the same thing by just dividing this by negative 3, and you end with a negative number here. But you need to be able to recognize that this answer here is the exact same thing as if I just divided that by negative 3. Sometimes the test will do that just to make it a little bit trickier on you. All right, here's your summary slide. Take a picture, make sure that you know all these things, and I'll see you in the next one.